Welcome back to Cognitive Processes. This is our last chapter, and we're going to be discussing reasoning and decision making. So let's talk about thinking, reasoning, and decision making. So the terms reasoning and decision making are often used interchangeably, and interchangeably with the idea of thinking. But cognitive psychologists distinguish among the meanings of these three terms. And so let's just take a look at these more clearly. Reasoning and decision making are probably special cases of thinking. Reasoning involves the use of principles of logic or the use of information to make inferences to create new information, whereas decision making refers to the mental activities involved in making choices among alternatives. So reasoning probably falls under the categories of deductive versus inductive. So let's just go over that. Deductive reasoning is generally reasoning that moves from general to specific, whereas inductive reasoning moves from specific to general. So how good are we at deductive reasoning? Well, if you've ever done the task that I'm showing you here, you know that we're not really all that good at it. It's challenging, it's really difficult. So let me give you one example here. So if you have a card that has a vowel on one side and then it has an even number on the other, if that's the rule, how many cards do you need to turn over to test this rule? So you have a card here, A, D, 4, and 7. Which cards would you need to turn over to check if the rule is correct? Okay, so the rule is if a card has a vowel on one side, then it has an even number on the other. What would you turn over to check this rule? Well, you have to turn over A and you have to turn over 7. Most people select the A but not the 7. And sometimes they'll needlessly turn over the 4, which, you know, because of the if-then rule, you don't need to do. So we're not very good at this. It's very tricky. It's very difficult. But context, we've seen this again and again in this course. Here it is again. The context matters. If you're working with this random information in the previous slide, then you are going to struggle. But if I give you a different rule that's actually the same kind of rule, but it's just more information related to real life, then people do a lot better with it. So if I have an example where I have 4 cards that say drinking a beer, drinking a Coke, age 16 and age 21, again, sort of a similar rule. If the rule is if a person is drinking a beer, then she must be 21 or older, then people know to turn over the beer card and they know to turn over the 16-year-old card to check the rule. It's easier, they do better if they have at least some contextual information that helps them do the task. So we are prone to struggle with this kind of reasoning. And then also we're prone to be led astray. So believability effects is one example where we're easily led astray. So imagine a scenario where you have some college professors are intellectuals, some intellectuals are liberals, therefore some college professors are liberals. It makes sense that, you see this pattern and you say, oh, that sounds believable, therefore it must be true. But just because you have something that sounds believable is not valid reasoning. And so when we are led astray by believability, it's not that we're doing something wrong. It's just like human nature to succumb to these effects. For most of the time, when we rely on these shortcuts, we're usually correct. And so that's when we sometimes rely on them unnecessarily, that's what leads us astray. Same thing with hypothesis testing. If you have a number sequence, for example, 2, 4, 6, and this number sequence follows a rule, you have to guess what the rule is. You don't say it. And then give me another 3 number sequence to test your rule. Okay, so think about this. The number is 2, 4, 6. What's the rule? Well, If you believe the rule to be ascending even numbers, you might test 8, 10, 12, or 100, 102, 104, for example. You might become more and more confident in your answer that your rule is correct. But you'd be wrong because the rule, unless you got this correct, the actual rule is just any three ascending numbers. Had you had tested 1, 2, 3, you would have realized that you were on the wrong track with your original rule of ascending even numbers. So in other words, we're prone to bias. Most of the time we come up with a hypothesis and then we test only sequences that obey the rule. We don't test the sequences that disconfirm the rule. In other words, this is why psychology students are required to take research methods and think through hypotheses and making sure that you are developing hypotheses that can help you understand if you're correct about something, but also if you're incorrect about something. The best experiment will be able to tell you if correct or incorrect about a hypothesis. Confirming or disconfirming a hypothesis is evidence is showing that. And the reason we try so hard to teach you about research methods is because this stuff is super difficult. Super difficult. We don't do it easily. It does not come naturally to us. So think about decision making. We set a goal or we revise a goal, and then we make some plans, we gather information, we structure the decision, we make a final selection. It seems like decision making would be really easy, but the reality is that all of this process doesn't always happen in a way that is so formal. In fact, we don't tend to gather enough information. We don't make concrete plans. We don't structure our decision. We're often swayed by emotions. Especially if it's a critical decision, then the emotions play more of a big role, right? And they shouldn't. And so our decision making oftentimes is not optimal. This is like what a computer would do, but we know that humans are not computers, are they? No. So the goodness of decision making cannot be measured by the success of individual decisions. A good decision is defined as rational if it considers all the goals, involves a careful gathering of information, and examines evidence for and against your initial inclinations. So, say you're trying to decide what you're going to invest your retirement money in. Are you considering all the relevant goals? How much money you need in retirement? Are you doing careful gathering of information of all the different retirement investments you can invest in? Do you examine the evidence for and against your initial inclinations? No, you generally don't, right? And so this is telling you that even important information like making sure you have enough money in retirement often doesn't follow this rational decision-making process. Poor decisions result from cognitive overload. So this is a good example. You have too many investment options. It's totally overwhelming. And then investing decades away in your future is also a strange cognitive overloading kind of task. It's not clear what you're going to even be like in several decades. And then you have the emotion piece, like, what if I don't have enough money? And you get panicky, and then there's the emotional component. So, I think one of the take-home messages from this chapter and looking at this topic is that we're not great decision makers. And if you know that, then you'll be a better decision maker. If you know that you're going to have limitations in making good decisions, that makes you a better decision maker because you can think through, okay, am I going through the steps? Am I really being rational? Am I gathering enough information? Am I gathering information for and against, not just for, but also against this option? And am I not cognitively overloaded? Am I not emotional? And again, if you want to take my Psychology of Money class, I talk about this endlessly. It's so interesting. Okay, so what are some of the heuristics leading to cognitive illusions that will lead us astray? Well, one is availability. We oftentimes, what is available to us leads us to go in that direction. Just look at this simple example in English. Is the letter L more likely to come at the beginning of a word or appear as the third letter of the word? Okay, so when you are faced with this kind of question, it's easier to think of words that begin with L. But words with L as a third letter, hard to think of. You really would have to think hard to actually even come up with one example, but it's actually more common in the English language. So the correct answer is the third letter, but because it's so available to us to think of words that start with L, then we are going to be led astray by availability. What about representativeness as a heuristic? Imagine you're flipping a coin 5 times. The first time you get heads, tails, heads, heads, tails. The second time you get heads, heads, tails, tails, tails. And then you're asked the question, which is more likely? We expect results to be representative of the processes that generate them. So even though both are equally likely, the one that more looks like it's flipping, heads, tails, heads, heads, tails, that's the one we're going to say is more representative, more likely in this situation, even though they're equally likely. It's a coin flip, right? That's why we make you take statistics and make you take, those classes that talk about probability, because it is hard to wrap your head around these things. It doesn't come naturally to us. What about framing effects? This comes up all the time in advertising, which many psychology students end up doing jobs in advertising for this very reason. So think about you're going grocery shopping. One store, store A, sells ground beef that's 95% lean. Store B sells ground beef that is 5% fat. Which store do you want to shop at? Most people say store A. They like the label lean, even though the two are exactly the same. So positive frames cause you to set a different reference point than negative frames. In other words, we take losses more seriously. Losses loom larger to us than gains. There's a whole, big literature on this. And so the Nobel Prize was based on this concept, Kahneman and Tversky. And so that kind of research shows us that we sort of we latch onto negative. We don't like negative. It looms larger for us. The positive stuff, is we gravitate to positive. We want to avoid losses and negative information. What about anchoring? So if you're given complex problems, we don't tend to follow through and do everything in a problem. And this is not just about math. This is a lot of different things. So imagine you're given research students in 2 sets. One group gets, a multiplication ascending problem, 1 times 2 times 3 all the way up to times 8. The second group of people gets the opposite, 8 times 7 times 6. And, they calculate that quickly and see what the answer is. Now, they're not allowed to use calculators. They're doing this in their head. And so what happens? You're not enough time to do the calculation. And so the groups typically perform the first 2 or 3 calculations and then adjust upward from this anchor because they didn't get to finish the calculation. And so the group A will often say a number like 512. The group B will say 2,250. And the real answer is actually 40,320. And everyone stays too close to their initial anchor and doesn't adjust enough. We're using a shortcut, and we do this with a lot of problem solving. So we don't, oftentimes when we're solving problems, work through all the necessary steps, and then we're not actually accurate. But the first couple of steps are going to bias our answer. And if our first couple of steps are helpful, great, but oftentimes they're still not going to lead us close to the actual answer. So if you think we're done with biases and decision making, there's many, many more. So think about sunk cost effects. It's a tendency to stick with a losing strategy because you've already invested so much in it. You think about money, that's an obvious example, but what about relationships? You've spent so much time dating a person and you're like, oh, I spent so much time with this person, I just need to stick it out. Well, you dated them for 2 years. Are you going to spend the next 20 years with them and when you know they're not a good fit for you? People are prone to the sunk cost effect. They feel like they should stick with it, even though in the long term they have 10 times as many years that they might be spending with this person. And if it's not a good match, they shouldn't be sticking with it. What about illusory correlation? We see relationships where there really are none because of some prior association in our mind. So we're prone to that. We're prone to hindsight bias. After the fact, we feel like we knew it all along. And hindsight bias makes it hard to learn from our mistakes and judging probability. You know, we think we knew it all along, but we didn't know it all along, right? If you have a journal is a great way to check your hindsight bias because you'll go back and realize you thought totally differently about an issue, and we don't remember accurately the way we thought in the past. And then confirmation bias, we seek out information to confirm our judgments, not to objectively test them. So, you know, we just we don't like negative information, do we? We like positive information, things that tell us that we're correct, things that tell us that, you know, we might be going in the wrong direction, makes us really uncomfortable. And we avoid them. And then overconfidence, we're all overconfident in our answers. It's just a natural human tendency to be overconfident. So imagine you're doing some trivia questions. When you are doing the questions, your accuracy and your confidence aren't always the same. And in other words, you know, you may be more and more accurate, but your confidence doesn't tie to that. This goes back to the lecture that we talked about eyewitness testimony. People can be very, very confident and very, very wrong, right? Never trust confidence alone. Confidence is a nice feeling, but it does not indicate accuracy. So there are a couple of different types of models that are used in decision making. There's normative models that describe ideal performance under ideal circumstances. Doesn't happen all that often in real life because we don't often see ideal performance in humans. We don't often have ideal circumstances. These are sometimes limited to the lab. We have prescriptive models that tell us how we ought to make decisions in real world circumstances. And then we have descriptive models that show what people actually do when they make decisions. And I think the descriptive models are the super interesting part. Humans don't make optimal decisions, and it's okay. We just need to study it and understand it, and then create environments so that we can help people make better decisions. You know, the default option. What is the default option in a scenario? Think about going in a cafeteria line. You know, if the default option, the first thing you see is a bunch of fruits and vegetables, then kids are going to pick up fruits and vegetables as part of their lunch. If the default option is the chips and soda, they'll pick that up. So, you know, people are going to pick what comes first. If we know that, then we can change things to make people make better decisions. Lastly, I just want to talk about neuropsychological findings. The prefrontal cortex is so critical for decision making. You've probably seen this so many times in so many courses. Phineas Gage's classic example where he had prefrontal cortex damage and he just wasn't himself. He just was impulsive and he just wasn't, you know, the same person, you know, not the mild-mannered person, more impulsive and you know, not making good decisions and, you know, patients with prefrontal cortex damage or dementias that affect the prefrontal cortex that we've talked about earlier in the class, they really have a difficult ability to reason and make good decisions. And decision-making tasks rely on the prefrontal cortex. It's the most human part of our brain. You know, it's what makes us uniquely, amazingly human, but also it's the most difficult thing we do in cognition is making these decisions. So throughout this chapter, if you saw lots of tasks and you're like, this is so hard, this is so hard, yeah, it's one of the most complicated things we do in cognition. So for review, human reasoning is variable, being affected by the way premises are phrased, content effects and believability effects. Decision making is subject to a number of biases and cognitive illusions. There's so many of them and we are very prone to them. So the more you know about them, the more helpful that is. The way people evaluate options is often inappropriately colored by how those options are framed. And people exhibit overconfidence in decisions. We're actually not great decision makers. We should be underconfident. We should have low confidence because we're not that great at decision making. But, our confidence is not tied to accuracy. And so if you know that you're overconfident, don't trust it, and don't trust it in someone else. And that's the end of this chapter.